Hi everybody, welcome to today's webinar where we'll talk a little bit about smart assembly. So just a quick agenda for the webinar today. So we'll talk about smart assembly. All of you that received that description, and I'll do a quick introduction about boundary systems. Then I've prepared a few slides on smart assembly. Then we'll jump into Creo and do a demonstration, and then afterwards we'll do a quick question and answer session. So just quickly a little bit about myself. So my name is Pierre Venter. I've been with Boundary Systems for about 2.5 years now, but we've been working with PTC products for the last 12 years. So just a little bit more about Boundary Systems. So these are the logos of some of the customers that we serve. Some of our capabilities is product lifecycle management, data management, CAD consulting, and design of CAD products, simulation, and product development. Some of our major accreditations, I think most of them PTC related, which are the important ones here. So we are a PTC Platinum partner. We're Winchell certified implementers, also a preferred service provider for the PTC products, and then also certified trainer or authorized trainer for Creo, Winchell, MathCAD, and Arbitex. So some of the solutions we offer, so I think the major ones are the PTC products. Then we have a few others, and Smart Assembly is part of the CMaxim products that we'll be discussing today. Okay, so let's get going with why we joined the webinar today. So it's to talk about Smart Assembly. So Smart Assembly is developed by B&W Software. Locally, like I mentioned in the other slide, CMaxim is looking after them. And then also some of the other software that you might have seen inside Creo is the Expert Mold Base extension, the Creo Advanced Framework extension, and also the Intelligent Fastening extension. So all of these are part of the same group, or they use the same technology. Progressive Die Extension, or PDX, is also part of that. So it's not just Smart Assembly, there's a few other products these guys do as well. Okay, so what is Smart Assembly? So Smart Assembly is specifically built for Creo and Winchell. It's taking technology that's there and it's giving you a nice graphical interface to design your products or make changes to them, or manipulate it in such a way that you can be more productive. Some of the additional capabilities they have is integration with ERP systems, databases, also work with Microsoft applications or Microsoft products like Excel and Word and things like that. So you can take that and you can integrate that into Smart Assembly. So I think the main reason, and we'll discuss it a little bit on the next slide, but it allows users to focus on designing products. So it's taking all the repeated clicks and the nitty-gritty things out of the design process and let you just focus on that design that you're currently busy with. So how do you do that? So standardization of assemblies and parts. So if you're working in a multi or in an environment where there's more than one designer, and each designer go out in its own direction, importing parts and building assemblies as they please, it can become a little bit of a mess. So Smart Assembly can help you to focus on and only reuse certain components according to company's standards. And I think one that I like most is new users can be more productive fairly quickly. You'll see as soon as we go into Creo, designing a certain hole according to a company standard. If you've been with the company for a few months, that's easy. But you take that learning curve for somebody new coming into the company out of the equation. So your design will be correct, the information on the drawing will be correct, and you drive all of that with SmartAssembly. And obviously that will give you some productivity improvements and speed up the whole process. One of the other things that's quite nice, if you're already using some of the functionality in Creo, so user-defined features is a big part of how we use SmartAssembly in a design environment. And if you use UDFs, it can become a little bit messy if you don't have a nice way of organizing that. SmartAssembly can help with that as well. And I'll show you a little bit more of that when we get into Creo. Okay, and then I think the big question is, so how do you write the code for SmartAssembly? What do you need to learn? And I can tell you, you only need to know how to work Creo. If you understand Creo and some of the functionality inside Creo, then you can learn this language that SmartAssembly is using fairly quickly and fairly easy. Okay, so it's easy to learn and it's easy to deploy as well. So you don't need programming background and things like that. It's an easy to learn language. And if you look at the screenshot I took here, if you read the yellow bits, that's basically telling SmartAssembly what to do. So search _MDL_REF is just search in a model for a reference. Okay, so and that's the theme throughout the whole programming section. Okay, and then also just an important bit, it's easy to migrate or upgrade. So you don't have to change anything if you're moving from Creo 3 to 4 or 5 to 6 or 6 to 7 and so on. These are all driven from, it's sort of like a text file. So so you don't have to worry about that. You can reuse them in later builds of Creo as well. Or you can create them in older builds and then reuse them in the later build as well. There's no issues around that. Okay, so I think that's the slides that I wanted to talk about. I'm going to put this information up, my contacting details. I'm going to put that up again, but you can take a quick screenshot of that if you want to. Okay, so let's go into Creo, and I'm going to start off with just applying some of the programs that's already there. So as soon as you have SmartAssembly installed, then you'll have this extra tab here at the top where you'll have all your SmartAssembly icons. So we'll be focusing on these lot for now, where we're going to add components and remove them and modify them a little bit. But this create new one, that's the one that the main focus will be on. Okay, so we need to add some bolts into this assembly. So I'm using bolts as an example. It's easy to explain. It's versatile. There's a lot of things you can do with that. So you have to imagine something in your environment where you can apply this, something that's repetitive, something that's annoying that you don't like doing, and you have to do it a lot. Then you can go and you can create or use SmartAssembly to do that for you. And let's say I'm going to add a bolt in here, and I'm just going to go into my section and I'm going to go into my library. So I'm only going to use 3 folders in here now, but there's no limit on these little programs that you can use. So So I've got 4 in this folder where I'm going to assign a bolt to an existing hole. Then I've created one where if there's no hole, I need to add the hole. Then I have a program for that. I have an auto bolt where it's going to calculate what bolts and things I need to add. And then I'll also have this little earpiece that I can assemble quickly or design quickly in a component. Okay, so I'm going to use this one for now. It's a nice interface and it's going to show us a few things. So just going to move this a little bit to the side. Okay, so during the slides, I mentioned the graphical interface. So these are just pictures that I've took off my component, save them as a picture file, JPEG or something like that. And then I tell the, when I do the graphical user interface section in my program, I tell it to use this specific picture. And that's how easy it is. I'll show you in the code as well. Okay, so let's quickly place a component. So I'm going to add a bolt, and you can see it's updating as I pick these. Do I want to include the nut or not? So just little tabs that I select, and then I need to say what nut type should be heavy, extra heavy, jam, or nylock. What type of washer? So that's all variants that I've programmed into this little section. And you can also see there's some required selections that I need to make. So you need to tell this program where to go and place it. Okay, so that's part of the versatility. So I'm going to say my screw placement here at the top, and then the axis that I should use, and then my nut placement should be on the bottom over here. Okay. So you can still see my little OK button here at the bottom is still grayed out. So I need to tell it what bolt do I want to add. So I'm just going to go pick my bolt that I want in there. And it's going to place that automatically. Okay, so we've done all of that. It's 3 components in one or in 3 clicks, or reference clicks that I had to make. But if you have to go tell a new user starting first day at the company, okay, so the bolt library is in Windchill, you have to browse there, and there, and then you get the bolt. The washers is in there as well. So assemble the washer first, and then the bolt, and then the nut. I mean, for a new guy, that can be daunting. Not the bolt scenario, but in your scenario where there's something a little bit more complex but needs to happen in a certain way. So there's an example of that. Okay, so the next one that I want to show is where there's not a hole. So we need to place the hole and the bolt. So let's go do that one. So we're going to say hole needed. So you can see again, nice graphical user interface showing us what we need to pick. So I can say include washer or not. In this one, I've added the thread that should be there. So once again, if there's certain company standards, so we use only 1.5 or 2, then that's a standard that you can program in there, and the user can't go and create a 2.5 or 3 thread. Okay, so let's say screw placement first. So I'm going to pick my top surface again. I'm going to pick my axis, and then again I just need to tell it what bolt do I want in there. So I need to pick everything, then my OK button will be there, and my bolt is assembled. Okay, so let's just see what happened here. So let's quickly hide that. Let's have a look. So you can see the other holes is not there yet, but this one is over there. and it created that in the cylinder part. Okay, so I made it to go, I'm in an assembly level, but I've made it to go and place it in the cylinder part itself. Okay, so that's also something that you can control. Obviously, in this scenario, it makes perfect sense to add the don't do an assembly level hole. The last one that I want to show you quickly is this ear one, because we're going to look at the at the actual program. And there you have. So there's some geometry created. Just put the edges on so you can see nicely what's going on there. Okay, so I've just picked the axis and it created that. Okay, so there's a few tips and tricks for something to work that quickly, and for that we need to look at the actual program that I've written. So let's quickly, so here's the ear program that I've done. Okay, so these programs are divided into certain sections. So you'll always start with the graphical user interface description. So that's the top bit. That's the bit that you see when you pick on this. So that's that little section, is that top section in the program. Okay? And then you get your assembly description section. So I've declared a few references or parameters in here, and you can see it's axis that I'm using, and then I'm searching the model tree for a certain plane. Okay, so as soon as you start using things like that, then those references should be in the parts where you're going to assemble them. Okay, so always try using something robust. Things that's part of the part of skeleton models or part of the start parts, things like that. That's all reference control you have to manage. Okay, so from there we're using user-defined features. So I'm going to create one now to go and actually go and place the or create the geometry. Okay, and then I'm just using different user UDFs as I go along. So you'll see there was different options that I could choose when I created the ear product, and I'm just telling it if it selected a certain reference, then run this UDF. So you can see fairly standard if statements, and then from there you just reusing information that was already created in Creo. Okay, so before I confuse you even more, let me start and explaining what a UDF feature is. So I'm going to go to a component. So you can create these UDFs when you're busy in a certain design environment and you're going to use it a lot over there, or you can create a simple extrude like this. Just add the references that you will be using, and just plan the whole thing a little bit. Then it's not going to be that hard. Okay, so we're just going to do a straight simple hole, and I just want to use a point selection. So the references that you specify here is fairly important, because that's going to drive the SmartAssembly placement at the end of the day. Okay, so I'm just going to use a point. So I'm going to create a simple hole. I'm going to pick the point, and I'm going to give it a value. Let's make it 1.5. And I'm going to tell it this should be a through all hole. Okay, so I've created just a simple hole. You don't have to name it something specific. You can do whatever you like with that. Okay, so now we're going to do the actual user-defined features. So you're going to go to Tools, you're going to go to your UDF library, and you're going to say Create. And then you're going to give your UDF a name. Okay, so I'm going to name mine Hole. And this is also important because these names will be used in the program later on. So just make a note of it, save it in a separate sheet, or I've made it part of of the programming text file. You can do whatever suits you. Okay, so that's my name. Well, I've already created that whole one, so I'm just going to name it something else. Let's call it something like that. Then we're going to say standalone. And I'm going to say done. And then do I want to include the reference part? No, you don't want that. We just want the feature, and we want the references that was used. So we don't need the reference part. So we say no. It's going to give us this little menu managers. So it's asking us to select the feature that we want to add to the UDF. So I'm just going to pick a hole here. You can pick a few things in here. If there was 2 holes created or something like that, you can do that. So I'm just going to pick hole. I'm going to say okay. I'm going to say done and done again. And then it's going to ask me for a prompt. So again, this prompt, you have to make a note of that. We're going to use it in the program. Okay. And then we're going to say done. Okay, so that's all we need to do. But we're going to take this an extra step. We want to vary a dimension in here. So, so we need to add that in there as well. So I'm going to say define. I'm going to pick the dimension that I want to vary. I'm going to say done. Done. It's going to give me a prompt. So I'm just going to give it a name, dia, something like that. And say okay. So now our user defined feature is, or our hole is created and saved. So now we can reuse that either in SmartAssembly, or you can just use it in the current design. Okay. So there was just one thing that I skipped here, and that is changing the dimension names. So something, just change it to something that makes sense. So if you highlight the or show the dimension and you go to switch dimensions, you can see the name. So D9, that's not making any sense at this stage. And if you're going to take it to a program, that's even going to confuse matters more. So what you can do is just going to double click that, and I can just change that to something that makes sense. I'm going to name that diameter of the hole as well. Okay. And that's that. Okay, so we can do the same thing, and we can add, we can create a hole for relief. So let's quickly create that hole. We use the same point. We're going to make that 2.5, and we're going to make that 1 inch deep. Okay, and that's fine. And then I just need to change the diameter one here as well. I want the depth to stay what I've specified it. Let's just change that D11 to D. Let's make it 2. Okay. Okay, and we do the same thing. Go tools, UDF library, create. Let's call it relief. I'm gonna go standalone. Done. Don't want to include that. We only want the second hole now. Pick the second hole and make note of the prompt again. And we're going to make that one variant one as well. Okay, and we're going to call this tier. Let's do that in capital letters. Tier 2. Okay, and done. Okay, so now we've created those user-defined features, and I just quickly want to show you how I use them. So, so the next section is going to be a little bit where I've already created them. So let me close all of this. And let's go to my installation directory, and let's talk a little bit about how things are managed here. So my working directory, that's just your normal where you will design things and not. And then you have your library section. And this is all the little programs that I've got. So we're going to work in module 1 for this one. And there's the whole UDF that I've created previously. And then let's open up this this whole program, the tab file. So if you look at this, there's going to be two things that I need to select. Okay, the point ref, the hole diameter, and then there's a checkbox that will be in there as well to add the relief, yes or no. So if you look again at my folder structure here, there's a relief user-defined feature. So that GPH file, that's a user-defined feature that I've saved. Okay. So then I'm going to run that UDF. So I'm going to use that in this section. Notice that select point. So that was the prompt when I created my UDF. Okay. Notice that diag that I've used. That's also the dimension that I want to be able to control. Okay. So that's there. So that's my UDF name. So hole. And then it's going to use a point reference that I've specified. And then if I said I should add the relief over there, then it should run this UDF as well. So then it's going to create a little relief section for me. Okay, so let's go and run this program and see what we've done. I'm going to close this down and let's go to my working directory, and we're going to open up an assembly, and we're going to go to SmartAssembly. I'm going to run that and go to module 1. I'm going to tell it the hole diameter that I want. So that's that dia that I've added, or in my parameter. I'm going to say 1 point. Let's make it 2.5 just for something different. And then my point reference. There's the point reference, and there's my hole created. So if we go and add the one with the relief, it's going to look like this. I give it 1.55, 1.55. I'm going to tell add relief, point reference, pick my point. It's going to add the relief for that hole as well. Okay, so that's just simple, a hole with some relief functionality. But the principle are exactly the same. If you start designing with it, that's the whole process that you will work through. Determine your references that you want to use, because my point was already here. But if you're going to use that, you need to go and create the points first, and then you can run the smart assembly application. So just think about what references you'll be used. If you're going to use user-defined features, think a little bit about how you would how you would name them and what parameters you need to vary. So yeah, so I think that's the major points that I wanted to show there. Okay, so let's go do another one, and let's just quickly look at that program as well. I'm going to open up this assembly. And let's see what we've done here. Okay, so let's just quickly look at the program first. I think it's a little bit easier to understand the program and then sort of try to see what will happen within Creo. So we're going to go to our second module. And let's quickly look at what's going to happen here. So we have a hole that's going to create with the UDF first. Let's open up this bolt program file and let's just quickly work through that. Okay, so by just looking at this, I can see we'll need to select a point and a face as a reference. Then it's going to use a specific part named bolt. And in that bolt part, there's a few references that's needed to place it. Okay, so I can see that. So let's quickly open up the bolt part. Let's just look at what exactly is happening there. Open the generic. So I can see there's a point, and that's called P that we'll be using, and then there's a datum plane base. Okay, so that's most probably where your alignment or your coincident constraint will need to be. So that's quite obvious. So we need those two. So that's created in the base part. So the program will line that up with whatever we select. Okay, great. Okay, so that's the references in there. Then we're just reusing those references. And let's so what's this UDF going to do? Oh, so it's going to use that whole UDF. See that over there? And it's going to create the hole for us as well. Okay, so very nice. So we're only going to select the bolt, and it's going to automatically create the hole for us. Okay, so let's go and do that. Assembly. I'm going to go into SmartAssembly, create that, go to module 2. Okay, so no diameters or no nothing. This is straightforward. A point reference. That's the point that I want to use. And then made surface, maybe that surface. And that's it. So let's quickly hide the bolt. Let's see. So there's the hole as well. So we have a specific bolt with a specific clearance. We don't want to change that. As soon as the designer places that bolt, the hole size should be something that's pre-programmed, and the relief is in there. Okay, so that was part of that whole UDF that we've created in this scenario. Okay, so yeah, so that's the coding and everything. That went a little bit quicker than what I expected. So I'm going to open up the question and answer sessions, and I'm going to put my contacting details back again. So get those questions in. I guess there will be a few of them, and then we can spend the next 20 minutes or so working through those. Okay, so I'm going to mute myself. Please go ahead and get those questions in. Okay, good. So we have a few questions coming in. That's great. Keep them coming. Okay, so the first one, can the SmartAssembly connect to a SQL database and get data from SQL? There's certain things that we can do. I'm not going to say yes or no right now. I will suggest you contact us. What we normally do is we'll review exactly what the needs are of the customers, and then we'll start on a solution. And then we also proof of concept that. So we'll make sure that you can do it. And if we need to, we'll get some of the expertise of Maxim guys in. So I'm not going to say yes or no right now. I need a little bit more information on the SQL database information. Then the second one, in case the bolt is changed, is the hole gone? Or can that be changed? Everything that's part of the SmartAssembly stuff. So let me just show my screen again. So if I go here and I say remove component, and I'm just going to pick the bolt, that hole will be gone as well. So if you use this environment to remove things that you've added with SmartAssembly, all of that will be removed. If you added it, you can go and change it afterwards with something like flexible modeling or something like that. But I guess the idea is not to do that. Okay, so things that you added with SmartAssembly, try to keep it as robust as possible and accurate as possible. But yes, you're still in Creo environment. You can go and chop and change and continue your design, which also make it a lot more flexible. So nothing is cast in stone, or you can change it if you need to at any stage. Okay, so let's see some other questions. Okay, so are the features easy to edit from the model tree after initial creation? Yes, it's a standard Creo environment, so so you can go and change that. So let's quickly add the bolt again, and let's just see exactly what has happened here. So if I open up this component, the hole is there, and that's a standard in the definition, and you can go and change as you please. So it's just the creation of that's making that easy. Okay. So yes, you can go and change it. It's normal functionality, but again, try to use SmartAssembly in such a way that you don't have to go and change things. But yes, you can. And then the next question. Can all the CAD items associated with the UDF and SmartAssembly be located in Windchill? For sure it can. Remember, this product is designed with Creo and Windchill in mind. So all my data was local on my laptop right now, but you can do it from a Windchill library as well. Okay. So let me say, so something like this, where you go and grab the information or parts in my local library, that library will just be inside Windchill. Okay. A normal folder structure or product as well. Okay. Can SmartAssembly be used for configuration assemblies, turn existing features on and off, change overall size? Yes, it can. Sorry, I did not do an assembly today, but yes, you can. So let's go to the, this bolt one will show it as well. So here's a typical how you would assemble something. So you can have if statements in your graphical user interface section. So if I select a certain option, then assemble a certain component, and you'll use coordinate systems. In this case, they used mate and an align functionality, so you can definitely switch certain things on and off as well. Okay. Once again, those rules are based on certain configuration options and company rules. So that's one of those scenarios where we would like to spend some time with you to understand what exactly do you need. How big are your assembly? How much options do you have when you do that? So yeah, so yes, we can. Give us a shot, and then we can take it a little bit further. Okay, so this is a third-party app, not a PTC app included with the installation. No, it is a third-party app and it's not included with the installation. But things like your intelligent faster, I think there's a free like a free version of that now, and I think the framework extension. So those are, I mean, that's the same developer of that software. So there's bits and pieces of it available in Creo, but not SmartAssembly as we're talking about it right now. Okay, so you can give us a shout. The sales, if you want to buy, there's a sales email that you can contact me directly as well, and then we can talk a little bit more about the product and how you want to use it. And then we'll get the sales side involved as well. So either email them or email me directly, and then we can start the process going. Okay, and then I've got one more question. I would like to use the cutout dimension plus cam references. If it's deleted, the cam would be lost. You can do that. There will be an extra step, and I'm thinking a little bit out of the box here. There's certain annotate features that you can link to and that's a sheet metal one. Here's the manufacturing. So yes, you can. I want to say yes, you can, Claudia. You can link the UDF with the cam, but all of that will need to be driven from an annotation feature. I think that's something I will try. So let's see if we can get that going. Give me a shout whenever you have some time, and let's see what we can do. Okay, so seems like the questions is dried up for now, and I'm going to mute myself for a minute or so. If you have any other questions, get them in and I will answer them. Okay, so there's no more questions. So I think I'm going to go ahead and end the webinar. So thanks for everybody that joined us today. We appreciate your time. Keep well.